Alright, so we're on to another lesson on Chapter 4. Previously we learned about divisibility and factors, and then we just learned about exponents. So today we're moving on to prime factorization and greatest common factor. A couple important things here. We're going to talk about these two words a lot over this lesson: prime numbers and composite numbers. A prime number is an integer greater than 1 with only two positive factors, 1 in itself. A composite number is an integer greater than 1 with more than two positive factors. So the reason that I gave you this list of numbers right here are these are all prime numbers. So there's a list of prime numbers between 2 and 97. Now some of you may say, well, hey, where's 1? Well, 1 is not considered a prime number. Now, I would like you to read through this activity and notice it says graph on next page. That's where I will be doing the activity. You might need to get a piece of paper out and follow along, but this is basically we're exploring prime numbers using graphing on a grid like this. Now basically they're asking us to find the number of rectangles you can make with each number of unit squares. So they're saying how many different rectangles can you make with 2 squares, 3 squares, 4, 5, 6, 7, 8, 9, and 10. So if I turn to this next page here, basically what they're asking us is here's two, and this isn't going to be pretty, but here's 2 rectangles. Okay. How many different ones can I make? Well, there's only one I can make for 2 squares. Some of you may say that I could make one like this, but technically that's the same thing, it's just rotated. Okay. Same thing with 3. If I wanted to choose 3, there's only one way to do it. But now watch what happens when we see 4. When we graph 4, again, I told you it's going to be pretty. Here's one way, but there is another way. See if you can think, and you can pause the video. See if you can think about what other way could I make this where it's not just this. Because remember, this is the same thing. Hopefully you got this. So there was a different way. Instead of just having one way like this or one way like this, we found a different way to do it. Now notice, this was 3. 3 is a prime number. 2 is a prime number, but 4 is not. So basically what they're saying with this activity here is if you were to graph 5, 5 is a prime number, you would only be able to, in the picture, it shows there's only one way to make a rectangle. 6, there would be more than one way. 7, prime number, only one way, and so on. So you should be able to answer those questions considering what we just talked about. So I would like you to finish those questions, but we're going to move on to the next activity. If you need to pause the video, go ahead. So we talked about prime and composite numbers. Prime numbers only have two factors, 1 and itself. Composites are just the opposite. They have more than just 1 in itself. So we're going to say, is 46 prime or composite? Well, I know through my divisibility factors that we talked about in section 2.1 that if a number is even, like the number 46, it's divisible by 2. So I would say this is a composite number. And why would you say it's composite? Because it has more factors than just 1 and itself. What about the number 13? Now if I go back to the beginning, I find number 13 on this prime numbers list, which means that 13 is a prime number because its only 2 factors are 1 and 13. Please, 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 in class, make sure you explain. You cannot just write composite or prime. Moving on to the next one. Now they're not asking if it's prime or composite. They're asking you to make a factor tree. And this is something that you guys should have seen already, but I'm going to demonstrate it with 273. And you guys can show me if you understand it in the example problem. Basically what we want to do when we make a factor tree is we want to put 273 right here. And we want to just basically break it down into factors, which are numbers that multiply to it. Now, in the end, we want all the numbers left to be prime. So I need to look at 273 and I need to think to myself, can I divide 273 by anything? Now, since I'd say I'm pretty good at math, I know that 273 is divisible by 7. So I'm going to help you guys out and I'm going to put 7 right here. So 273 is divisible by 7. So what happens when 273 is divided by 7? You would get 13. So 7 and 13 are both factors of 273. Now, if this was not, these two are both prime numbers, so that means that I would circle both of these, and the prime factorization of 273 would just be 7 times 13. Now, what if I wanted to do an example like this? What if I gave you the number 56? Well, I can break my factor tree into a bunch of different things. It doesn't matter what number you break it into first. If you want to do, let's say, let's go 8 and 7. Well, 7's a prime number. But 8 is not, so I have to break that down even more into 4 and 2. 2 is a prime number, so I circle it. 4, break it down to 2 and 2. So now I would write this, 56 equals 2 times 2 times 2 times 7. But actually, the correct way to write this is, since we just talked about exponents, it's actually 2 to the, I see 3 different 2's, so it's 2 to the third times 7. In this one, we have to find the greatest common factor, which basically, how you find the GCF is you have to find what they have in common. The greatest common factor means the biggest number that goes into both numbers. So how do we find these given two numbers? So if I have the number 24 and 30, what I like to do first is I like to make two factor trees. I choose to do it by 6 and 4, and then I'll make this one 6 and 5. These are both not prime, so I'm going to break it down even more. 3 and 2, 2 and 2. So now, prime, 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 I know that 24 equals 2 times 2 times 2 times 3. Now notice, I left it like this because I want to show you why it makes it a little bit easier. Going back to the number 30, 5 is a prime number. Break this down, 3 and 2. So now I have 30 equals 2 times 3 times 5. Now how do you find greatest common factor? All you have to do is once you write these down like this, you have to find out what they have in common. So they have a 2 in common. They also have a 3 in common. The 2 and the 2 and the 5 we're not going to worry about. So they have a 2 in common and a 3 in common. That means you take one of the 2's. Okay, you take one of the 2's and you take one of the 3's and you multiply them. 2 times 3 is 6. So the greatest common factor of these two numbers equals 6. The next one, everyone's going to start panicking. Oh my gosh! Because there's variables, but let's not worry about those right now. I'm just going to basically cover them up like so. And I'm just going to focus on the 36 and the 81. Now, I know 36 is broken down to 6 and 6, which breaks down to 3 and 2, and 3 and 2. So that means if I want to write 36 equals 2 times 2 times 3 times 3, that would be great. Okay, that's a very smart thing to do. 81, 9 and 9, 3, 3, 3, 3. So that means 81 is broken down into 3 times 3 times 3 times 3. Now, we have to find what do they have in common. Well, 81 doesn't have any 2's, so it's just the 3 and the other 3. So remember, we only take one from each. 3 times 3 equals 9. Do not do 3 times 3 times 3 times 3 because we know that that equals 81. 81 doesn't go into 36, but 9 does. So the greatest common factor is 9. But wait, we're going to keep this 9 and we're going to make sure we remember that. But I'm going to go back here, and now we have an AB squared and a B. Now again, we're not going to panic, right? We're just going to write out AB squared and B. Now, what does b squared mean again? It means that there's two b's, so it's basically a times b times b. And this one just has a b. Well, what do they have in common? B doesn't have an a, so a's out. Now, b in common, b in common. They don't have another b in common, so that one's out. So what do they have in common? Just one b. So that means our answer is not just 9, it is 9b. The variables are a little bit tricky, but as long as you write them out, and you can go ahead and write them out like this if you want, a times b, and then below it just put a b here, because now you know these line up and these do not. So now you just take what they have in common. Make sure you ask questions tomorrow, please, and make sure that we understand what we're doing with this, because this is a big part of our unit test at the end.